This part of the lesson is called exponential function transformations. And I'm going to tell you guys something to make you feel a lot better. Because we've already done an entire unit on transformations, this is really going to be very easy for you because we use exactly the same concepts that we did then. We're going to use mapping coordinates, parent function, and transform function. All of it's going to be the same. The only difference is because this has an exponent, it looks a little bit weird. So you just have to get used to the weirdness. You should know the parent function always looks like b to the power of x. And then the transform function is going to have a whole bunch of stuff added to it. For example, you can have a number in the front. You can have a number at the end. And then you can have a whole bunch of stuff in the exponent. Before we go through the chart, just from knowledge from before, what do you think the A and the C are going to be? Do you think they're going to be vertical transformations or horizontal? Good. They're probably going to be vertical. And you know how I keep saying stuff inside of the bracket? Well, in this case, stuff inside in the bracket is actually going to be in your exponent. So anything in your exponent is going to affect your horizontal. Okay, so I have a little chart for you guys here. We're going to go through it, and this kind of just outlines all the different transformations. If you have a number multiplied to your x, that tells you if it is a horizontal stretch or compression. And just like before, you take the opposite. So for example, if I had like 3 to the power of 2x, you're not going to think of that as a 2. You're going to think of that as a half. And it's going to be a horizontal compression by a factor of half. So remember when we did transformations, anything in the bracket is always the opposite. If you have a number in the front over here, that tells you if it's a vertical stretch or compression. Nothing changes. That's exactly as it is. If it's a whole number, it's a stretch. If it's a fraction, it's a compression. Reflection. So if you have a negative in front of everything, that is a vertical reflection. Remember, vertical reflections are like this along the x-axis. Question? Oh, we'll get to that when we do examples. That's a good question. Yeah. And then for the reflections, that is a horizontal one. It's going to be in your exponent, and a horizontal reflection looks like this. It's along the y-axis. Then a vertical translation is just a number over here. If it's a positive, it moves up. If it's a negative, it moves down. And if you have a number attached to your x in the exponent, that's a horizontal translation. If it's negative, it moves to the right. If it's positive, it moves to the left. Which one of these do you think affects your horizontal asymptote? There's just one thing that affects the horizontal asymptote. What do you think that will be? What do you think is going to shift that asymptote up and down? Justin? Good. So the vertical translation is actually going to tell you where your asymptote goes. So if you have a number like in your C position, then that right away is going to give you your hint as to where your asymptote will be. Okay, so let's practice identifying this information in this chart over here. We'll do all of them together. I think I just want to do questions 1 and 2 today, and then we'll probably stop there. And we'll continue the rest of it tomorrow. All right, so for question 1A, the question says all of our parent function is f of x is equal to 2 to the power of x. So if you see 2 to the power of x in any of these examples, that 2 is not a transformation. That 2 tells you your base is actually equal to 2. So anytime you have a parent function, whatever the number is, it's not a part of your transformations. And I'll always remind you of that because that part can be a little confusing. So if you take a look at question 1A, we have a positive 5. How would you describe that? Like in words, vertical translation, 5 units up. Are you guys okay if we use short form just for the chart, knowing that in a test you have to use full form? Yeah, okay. So for this, I'm just gonna write vertical translation, 5 units up. And just so we can practice doing our mapping coordinates, if it's a vertical translation, does it affect your x or your y? Good, so your x value will stay the same, but for your y value in this question, you would just add it to the y. So it'd just be y plus 5. Okay, I'm just gonna go to C. I think I'll just go downward. So I have x minus 3. What do you think that will tell? What kind of transformation is that? Horizontal translation, and where are we going? Good. 3 units to the right, because anything in the exponent will have to be changed. So if it's a -3, you're thinking of it as a +3. So horizontal translation, 3 units to the right. Horizontal translation, will that affect your x or your y? Good. So it's going to be x plus 3, comma y. Okay, and make a note to yourself that even though it's a -3, it changes. Anything in the exponent is going to change, like the sign or whatever. Okay, question E, what do you think that will be? 3 times 2 to the power of x? A vertical stretch by a factor of 3. Good. So vertical stretch by a factor of 3. And if it's the vertical stretch, does it affect your x value or your y value? Good. So it's just going to be x, comma, 3 times y. If this number, by the way, was a fraction, then it would be a good. So if you take a look at example G, the difference between example E and G, they both have a number in the A position, but 3 is a whole number, so it's a stretch. But G is a fraction, so now it's going to be a vertical compression by a factor of, I'm using super short form here, by a factor of a quarter. And is that going to affect my x or y in the mapping coordinates? Good. So it's going to be x, comma, 1/4 y. Let's keep going. Let's go to question letter B. Here we have f of x is equal to 2 to the power of -x. If the negative is in the exponent, what kind of reflection is that? Good job. Horizontal reflection along what axis? Yeah, and so horizontal reflection along, and the way I think about it is horizontal side to side, so it's reflecting along the y-axis. Anything horizontal is going to be affecting your x value in your mapping coordinates, so all you would have to do is change all your x's to -x. And then if the negative is on the outside, that is a vertical reflection along the x-axis. And then how do our mapping coordinates change? Your y is now going to become negative. Okay, I left the hardest for the end. Here we have 2 to the power of 3x. Make a note to yourself just to review this, because this is the hardest one. And that's because, see that 3? Because it's in the exponent, we're not going to actually think of it as a 3. We're going to think of it as 1/3. So you always switch everything in the exponent. And if we think of it as 1/3, is this a horizontal compression or a horizontal stretch? Good. So it's going to be a horizontal compression by a factor of 1/3. Anything horizontal affects your x, and we're going to use 1/3 in our mapping coordinates as well. So it's going to be 1/3x, comma, y. But honestly, because we did a whole unit of this, I feel like this part, it just doesn't make a lot more sense now, or at least you know what to do a little bit easier. I'm going to rewrite this last example so that instead of a decimal, it's actually a fraction. So it's going to be f of x is equal to 2 to the power of 1/2 x. And I'm doing that because when I take the reciprocal of 1/2, what does it become? It becomes a 2. So is this a horizontal stretch or compression? Yep, it's going to be a horizontal stretch by a factor of just 2. And we're going to multiply that x with 2, so it'll be 2x, comma, y. For question number 2, it says, identify the base function, and that is so crucial when you're doing questions like this. You always want to start by identifying the base function, and then state the transformations applied from the base function. So how exactly do we find the base function? I'm going to show you. You look at the entire jumble of the equation and you ask yourself, which one of these numbers is attached to the exponent? So if this entire thing is the exponent, the only number that's actually attached to it is the number 3. And so that means our base exponent is y is equal to 3 to the power of x. While we're doing this, let's actually, no, we'll do it again for the next one when we get to it. Now it's important to identify that because the 3 is not a part of any of the transformations. We're not going to include it as part of a transformation. It's part of the original function. Let's go in order and identify all of the transformations. So what do you guys think the 2 represents? By a factor of 2. I won't, because we have room this time, let's just go ahead and write the whole thing. So vertical stretch by a factor of 2. If the stuff in the exponent was not factored, we would have to remember to factor it. Question? You don't change the number in the front to anything. That remains as is. So if it's a 2, it remains a 2 and it's a stretch. The only thing you change is anything in the exponent. Yeah. Okay, you guys. I have a question. And my question is, what was my question? What was I just saying? Oh yeah. No, I have something to tell you. I don't have a question. Do you guys see all of the stuff in the exponent? Do you see how it's already factored? If it wasn't factored, you would have to factor it before you do anything. And we will get to examples where you're going to have to do that. We have a 2 over here, but we're not going to think of it as a 2. We're going to think of it as a half. That would be a horizontal compression by a factor of a half. How about the x minus 4? What would that be? Horizontal translation 4 units to the right. And then finally, we have a plus 1. That would be a vertical translation 1 unit up. Yeah. While we're here, let's also figure out the mapping coordinates. So what would affect your x value? It would just be the stuff in here. The 2 will become a half and the negative 4 will become a positive 4. So it would be a half x plus 4. What would affect your y values? It would be this 2 and this positive 1 and nothing changes. So it would just be 2y plus 1. While you're all attentive, go ahead and try question B. But before you do B, we have to actually factor the exponent. So do you notice how it's f of x is equal to negative a half? And see how it's negative x plus 2? That's not allowed. And that's a really big error that a lot of students make. Because if you don't remember to factor it, then really the rest of your graph and question will be off. So make a note to yourself, you have to factor the negative. So it's going to be negative bracket x minus 2. If we want to identify the base function in this, by the way, what would it be? Yeah, y is equal to just a half to the power of x. This one doesn't seem to have as many transformations. So let's go ahead and start with the negative. What does the negative on the outside mean? What kind of reflection? Yeah, it's going to be a vertical reflection along the x-axis. We also have a negative in the exponent, so that would be a horizontal reflection along the y-axis. And then the last transformation is the negative 2. That would be a horizontal translation. You got it. 2 units right. And just to finish this off, you guys, if I did want to write the mapping coordinates for this, it would be, what would it be? Negative x plus 2, comma, negative y. Yep, that's it. So we're going to continue the rest of it on tomorrow's class.